Good afternoon, everybody. Today, we're going to talk about migrating a U.S. Army application to the cloud. What we're going to kind of cover is really discuss how we worked at HPE Enterprise Services. I'm Stu Hammer. I lead our U.S. public sector HPE Enterprise Service practice, and I'm going to introduce our distinguished speakers here, but how we work together with the U.S. Army to migrate an application into the GovCloud, lessons learned, what worked and what didn't, and we'll facilitate some questions right at the end. So first of all, I want to introduce, Bob Torch. Bob is a retired U.S. Army officer, 31 years in the military and both civilian, working right now as a civilian project manager for the Total Ammunition Management information system called TAMIS, which we're going to be talking about. And he's responsible for the TAMIS contract, the planning, the implementation, and really driving that implementation into the GovCloud environment. Additionally, Bob serves on the Cloud Migration working group for the U.S. Army. And one thing I'll just kind of add, because it's pretty significant, TAMIS is one of 4 applications that's really been pushing and driving into the GovCloud environment with the U.S. Army. And I think you'll hear that we'll get some really good lessons learned and experience. Next, Bill Link. Bill Link is a practice principal in my U.S. public sector practice. He's a certified AWS solution architect. He leads my cloud application to transformation group. And Bill has over 26 years experience, many of them in DoD and Intel. And he has been able to take that forward and really leverage that into this migration activity. So on that, I'll turn it over to Bob.
So what I want to do first is sort of start off by talking about what TAMIS is and what it does for the Army. And by the way, it also works for the Marine Corps as well. And then I'll turn it over to our HP Smart guys here who actually did the physical movement of the application to AWS and to GovCloud. So first, just a little bit about TAMIS. TAMIS is the Army's requirements and prioritization system that administers ammunition management for the force. So what that really means is that what a user does with TAMIS is it manages the authorizations, calculates requirements, how much ammunition am I going to need, where am I going to need it, they forecast it, they determine where they're going to need it, they go into TAMIS and they'll forecast it. The industrial base ships the ammunition to where the soldiers say that they need it, and then the soldiers go back into TAMIS when in fact they need to draw the munitions, and they create what's called an electronic request, and that request is done on a computer screen. It's digitally signed with the soldier's CAT card. Most of you may be familiar with the CAT card, and so we use that as a digital signature for the requester, the approver, and sometimes there may be another signature in there as well. It just depends on what the workflow is for the type of munition that's being requested and what account it's being requested for. And this includes all the rockets, missiles, and mortars that we fire all over the world, but mostly fire in training in the United States and in Europe and Korea. The Marine Corps uses the system for pretty much the same kind of function. So they do their requesting and their authorization and their sub-authorizing and their day-to-day munitions management functions with the system. And collectively, those results come back to the system, and then the Army looks at what we've expended and then uses that data to assist in procuring the additional munitions that we need. Some of them have a long lead time. That's kind of in a nutshell what the TAMIS system does. What I want to focus on here or mention here is that we built the system around the Microsoft application. I mean, currently the system is sitting in the Pentagon. It's sitting in a traditional server-based environment. And a couple of years ago, and many of you probably know this as well, that there was a mandate for migrating systems to the cloud. And there was a FY18 date established that systems were supposed to be migrated. Whether or not the Army meets that, probably not. It'll probably be required to be extended somewhat to move all of our systems to the cloud environments, whether they be Amazon or someone else. So back in 2014, we looked across the spectrum, and we were getting ready to award our contract, and we submitted, this is for the TAMIS contract, and we put it out to bid, and at the same time we included in that contract was the requirement to migrate the system to a commercial cloud provider. And in there we stipulated, we entered the pertinent information about, you have to do an analysis, you have to determine what the costs are. Is it really make more sense to go to a commercial cloud provider or go to MilCloud or to some other cloud environment? And at the time, there were really few offerings available to select from, and of course Amazon was the king of the hill at the time with their PA for Impact Level 4 systems, which is what TAMIS is. And so when the TAMIS contract was awarded, it was awarded to HPE, and they got the task then to move the system in. In 2014, we actually started in December of that year. The system was migrated. A couple of months later, the migration process, in my estimation, as the manager of the system, was easy. I mean, it's easy to move a system to Amazon. And we chose the forklift method, and if you review the Amazon, or AWS, I should say, I suppose, if you review their documentation, you see what the process is for forklifting. And that is just simply one method that we chose. It may not fit all system owners. And HPE conducted that. The second part of the process was to tune that application, tune the system to load balance and multiple availability zones, and tune the application layer and the database to make it more efficient than it is today sitting in the Pentagon. And that's what Bill over here is going to talk about, the process that they went through to optimize and make the system more efficient, more cost benefit to the Army, and more productive for us.
Thank you, sir. Well, Bob, thanks for setting it up for me. Bob gave us the why and the what, and as he said, I'm going to talk a little bit about in terms of how we actually went through the transformation. And as part of the overall offering that we presented to the Army, it's part of our application transformation to cloud offering. And there are three major steps that are part of that process. The first is the assessment of the application, and that's about understanding whether or not the application is truly ready to migrate to the cloud, and what holes are there, what gaps are there, what do we need to do in order to make it most efficient in the cloud environment, what target environments are acceptable. So we did that assessment and understood that TAMIS was a great application to migrate to the cloud, but also to the U.S. government cloud because of its security requirements. Then we defined the target architecture, and all the solution architects that are sitting in the room understand that there are always trade-offs in terms of architectural considerations. So not only did we go through the various options that were available to us, taking into consideration best practices at the time, security requirements, but we developed a roadmap, and that's part of the transformation that Bob spoke about in terms of we first did the Amazon forklift, and we call that a rehost in our terminology, and then we did the optimization not only at the database tier but the application tier to make sure that application runs as efficiently as it can be from a technical as well as financial perspective. And then we went about the business of actually transforming that application so that it would actually run in the environment. The graphic that you're looking at on the screen is a representative example of an application assessment graphic, and it shows an evaluation of the application not only from a mission perspective, but also from a technical perspective. And there's a variety of characteristics that we evaluate. We'll talk a little bit about those in just a moment. There they are. So there are about 17 different characteristics that we looked at. Now I'll speak about a couple that were really important for TAMIS. Workload variability. We understood that TAMIS had a variable workload in terms of requirements. There are periods in which there are a greater number of users than the average workload, and there are periods of time in which there are deadlines that need to be met. So we wanted to be able to take advantage of the scalability, elasticity of the cloud environment to support TAMIS, and we also understood that in a production environment there were bottlenecks associated with the database and reporting requirements that we needed to remedy. And then understanding the software license restrictions or agreements that were in place and understanding whether or not those were sunk cost or opportunities for us to be able to take advantage of some of the things that we already had in place. One example is obviously in the Amazon environment, you don't get to bring your OS, but you can use your own license when it comes to your database. So those are trade-offs that we needed to make. We looked at a variety of concerns, and these are the major recommendations that we had for TAMIS, and this is actually how TAMIS turned out in terms of our assessment. It was fine from a technical perspective. There were some issues from a mission alignment perspective that we wanted to take advantage of. TAMIS was not totally ready to take advantage of scalability from a horizontal perspective. We typically scaled infrastructure from a vertical perspective, so we needed to remove sessions from the app tier, and we used DynamoDB to manage our sessions and did some minor architectural changes in order to take care of that concern. And then we also needed to have the servers to be able to auto-build or build without any human interaction in order to take advantage of scalability. Secondly, we did some things as it relates to the database. We made that a high availability configuration, and understood that was there was a high availability requirement there. We needed to make sure that we took care of that issue, take care of the predictable load balancing issues or database spike issues. We wanted to make sure that we had the common access card was available not only in the training environment but the production environment. And one thing that we didn't have is a consistent way to test the application that was automated. And anytime you're moving to the cloud environment, it's much better to have those tests automated and repeatable so that you can actually prove that your application is running in the environment appropriately. So, as Bob mentioned, our first effort was the Forklift effort, as we know it in Amazon terms, rehost in AWS terms, and our objective there was to get the application up and running in the Amazon environment as quickly as we could, taking advantage of those core services, EC2, enterprise block storage, S3 buckets, and just the basic services, get the VPC up and running, prove that we could in fact use AWS core services and protect our application, utilize the environment, get the account up and running, and be able to if we wanted to, shut down the legacy environment. And that took us about 6 weeks without taking into consideration the acceptance testing, but the actual development work and transition. And once we were there, then we moved on to the other phases, and we called those the optimization phase. And we basically had 2 major iterations within the optimization phase. So from a time check perspective, I don't know if we could get the clock running, but we can make sure it's 4. Okay, thanks. So from an optimization perspective, we basically had the database tier as well as the application tier to optimize. And the database tier, as I mentioned earlier, we wanted to take advantage of the high availability configuration that was available to us. And so we put the database not only in two availability zones. It was a SQL Server database, so we utilized always-on configuration in SQL Server to have a read-only instance. And we actually did some refactoring of the application in order to take advantage of read transactions versus read-write transactions. And we sent all of our read transactions to the read instance. That allows us to take some of those reporting concerns off of the main database, and it also allowed us to scale the slave database as needed in order to provide the reporting in the high transaction timeframes. Minimal code changes, automated delivery was also a major piece of that iteration. We started to do infrastructure as code and parameterize all the major scripts, and we utilized JSON, PowerShell in order to be able to do that. And I think we mentioned earlier that we're a .NET environment, so that that was important for the next tier. The next phase was optimizing the application tier. So we created scripts to start the service without any human intervention and began to bootstrap. It's a common term in the AWS environment actually in the technology world that talks about building servers from the bottom up. And then we created auto-scaling groups to take advantage of horizontal scaling, and we put in elastic load balancing to transition traffic back and forth and make our application tier a highly available environment. One of the things that we noticed as we began to go through the optimization is that we had originally priced the environment basically to be the size of the environment that we had in place. And we began to see some efficiencies in terms of utilization of the capacity that was out there. And so we downsized some of our servers, and we downsized some of our memory, and we saw significant cost savings, not only from moving to AWS from the cost model perspective, but there were technical efficiencies that we didn't consider as part of the overall assessment that we took advantage of. And so we use smaller, more efficient servers, memory, and other components to actually save money and utilize the environment. Finally, I think I actually covered everything there from an optimization perspective. So we'll move on to the next slide. So I mentioned over the period of time that we had a variety of different components that we wanted to test out, and Bob mentioned that we were a pilot program. It was important for us to utilize as many of the AWS services as possible. And what we tried to do is utilize every one that had a provisional ATL. And so this is the list of services that we actually used, and we used them extensively through the various phases of the project. Elastic Cloud Computing, Elastic Block Storage, our S3 buckets, Virtual Private Cloud. We used Identity and Access Management not only to manage access for our developers, but also in signing for the S3 and even in our building capabilities at this point in terms of release management. Elastic load balancing we began to take advantage of in the application phase of the project, and auto scaling, and the one service that we're utilizing that doesn't have a provisional authorization is the Amazon DynamoDB, and we believe that we'll get that cleared before we actually get our ATL. Now, let's talk a little bit about DevOps and some of the things that we took advantage of from a DevOps perspective. The driving force for DevOps was really two things. One was the frequency of change that occurs from a mission perspective in terms of requirements and the capability of the system encouraged us to be very flexible and try to get as much of the capability to the end user as quickly as possible. So we wanted to do that. And then the environment is very conducive to taking advantage of some of the DevOps concepts. And we absolutely had to do the testing piece. So there are three sort of drivers there that we needed to take advantage of. So from a DevOps perspective, we had initially implemented regression testing. That went from several days down to many hours when we initially did that in the initial release. And that was a significant improvement from our perspective. And we continue to have a lot of those advantages today. Since then, we've implemented 4 to 5 for our code scans, and we build on commits so that we get our reports back on a daily basis or nightly basis, so that developers understand from the perspective of clean code that they've got a feedback cycle in the early part of the process, so they understand where there are issues and they can discuss that, and it's cheaper for us to actually fix those problems early on in the process as opposed to catching them during regression testing. And here's a list of all the different tools that we're using from an automated testing perspective. We've used HPE Unified Functional Test, our load runner capability for performance testing, and we're also using Microsoft Test Manager because we do have quite a bit of that going on from a Microsoft perspective on the project. Now, Stu, please feel free to come on up. I was just getting ready to bring Stu back up for questions. So,
Well, just to kind of summarize, so these guys did a great job, but in 3 months or so, we took this application, we were able to rehost or forklift it into the AWS environment, and then began that assessment. So Bob was right, it seemed easy. Bill might debate whether how easy it was, because there was some aspects, and I wanted to kind of set this up, that we really wanted people to know, especially from a government, a DoD perspective. We really had to do a top-down, bottom-up analysis of that application, shake out what are the vulnerabilities, what are the risks, what are the challenges as we migrate it. And that wasn't just because we felt we had to, we were required to do that. Bob was taking a chance, so to speak, to be that first cloud provider by the U.S. Cloud application in the Amazon cloud, and we had to do it right. We didn't want to make any mistakes. So one of the questions I wanted Bob to ask, what were some of the challenges you had being that first, and how did you get that through the Army, and explain to us some of the
it's
things.
Certainly a culture change for many senior leaders who've come up owning their data and owning their system and being able to reach out and touch it, and you say, well, we're taking the Army's complete ammunition management system and we're going to Amazon, and their eyes light up, and it's kind of stunning. But after a while, people begin to realize that, and the culture begins to change. And I think now we've come a long way. We've come far enough now that there's a bunch of apps that are sitting in the queue waiting to migrate, whether it's to Amazon or to some other commercial cloud provider. The system owners have recognized that efficiencies can be obtained and improvements can be received as well. The challenges that we have, and I've mentioned them in an earlier session, have to do with connectivity to the DISA cloud access point and CND, the network defense piece. Now, sitting in the Pentagon, our network defense is provided by the joint service provider, so I don't have any cost for network defense. I go to Amazon as a systems owner in the Army, And I now incur that responsibility myself for my project. So I have to pull money from somewhere in order to pay for something I was already receiving at no cost. So the Army is pursuing ways for system owners to achieve their CND requirements, their network defense requirements, by using a service provided by Netcom or arranged through PEOEIS in some kind of contract arrangement. But those things aren't available yet, and those remain challenges for system owners to this day, especially at the impact level 4 level. So once those get resolved and connectivity to the CAP can be established and the routine is identified, then I think there will going to be a whole host of systems, particularly from the Army, that are going to be moving to either commercial cloud or down to maybe Redstone, where the Army is pursuing turning one of its data centers into a commercial operation. So we'll see how that works out. But this push for cloud is really taking hold, and system owners now see the benefits.
Bob, one more follow-up question. So Bill mentioned, we got it into the cloud. We're successfully operating it in the cloud. We implemented a DevOps approach, and the DevOps approach gave you, the customer and the Army, opportunity. So we, just to highlight, we went from releasing the potential to release over a month down to a day. We took testing from 3 weeks down to 3 hours. What just, obviously that can be happiness. Tell us what opportunities that opened up for you guys in the
Well, it's certainly
Army.
cost savings, that's for sure.
Yeah.
So when my contractors don't have to spend all their time testing, they're available for other services. And while all this migration is going on and all this work is being conducted, oh, by the way, they're still administering the existing system. So they're still have to do the help desk support, respond to trouble tickets, troubleshoot other kinds of issues that are occurring in the application when there's some kind of data collision that may occur. So they're still going about their day-to-day systems management of the application while they're also building or transforming the system into a cloud. So we're able to certainly able to save time and resources that free them up to do other things.
Thanks, Bill. Kind of rolling back to the beginning, when you were starting to assess the application, looking at it for the suitability for the cloud and determining, what's the good, the bad, and the ugly of this application, especially around security, which was, and the risk management. Tell us how that worked.
Well, part of what we did was we did a code analysis, and we analyzed the code in terms of code walkthroughs, and then we actually performed a scan on the code to understand where we stood from a vulnerability perspective. And then we also looked at the regulations and requirements that were contractually applied to us. And then Bob mentioned that we needed to make sure that we were able to handle CAT-CART implementation. And that was something that was in the production environment but was not in the training environment. And we wanted to be able to do that for the future release and make sure that it worked in AWS before we moved over to production data. So that's part of what we did, and we utilized not only our tools but our personnel to be able to do so.
How about just a follow-on? How you really dove into the risk management framework, and kind of tell us a little bit about that.
Well, risk management framework has a variety of components to it. One of which is the code scans or the scans that are necessary in order to provide the STIGs and so forth. So as part of the delivery of infrastructure as code, we understood that we needed to apply those things to that environment. And so we built actually gold copies of the infrastructure stigged out, and then the additional parameters that we couldn't do from that perspective, we were actually able to apply to the other components and do that as infrastructure as code, so that no matter what environment we decided to build, we were able to deliver it from a DevOps perspective as code and verify it and version control it, and that was an additional piece of capability that we didn't have before.
I wanted to open it up to any other questions that you might have in the audience. Sure, go ahead.
I have two questions. First one, in regard to the forklift of moving the application to AWS, was it an actual move? I'm unsure if the original application is physical or is it virtual?
It's physical.
It's physical. So was it an actual rebuilding of the application within AWS, or did you use some method of actually doing a P2B and getting it into
We did a rebuild. We rebuilt, recompiled, rebuilt the application. Matter of fact, we needed to do some component upgrades in order to make it fully operational in the AWS environment.
And then the second question has to do with the CAC authorization. So you have it working now with the Amazon IAM to actually enable that CAC authorization, as well as the authorization?
We actually don't go through the Amazon IAM in order to do that. And one of the graphics actually has the Akamai as a component, and we utilize the Akamai component in order to do some of the verification for CAC.
For the authentication?
For the authentication, yes.
Is the authorization being done within the application?
Yeah, authorization for functionality is done inside the app.
From a system owner perspective, I'm not sure if there's any system owners out there, but I would highly encourage the use of the service from DISA through GCDS Akamai for CAC sign-on. Now, DISA provides GCDS to the service components at no cost after the $40,000 configuration. And after that, there's no cost for the Akamai component that DISA has. Now, the challenge to that is if you have an application that also is accessed from the .com side, then you need commercial Akamai. So we engage both the DISA GCDS, which we're not paying for, that's paid for by Big Army, and then we're also paying the bill for the commercial side. So we're protected using the web application firewall. We use their site shield and the CAC logon feature. And from a service perspective, it's the best thing any system owner could do.
So the commercial one allows you for the ECAs, so .coms or other .govs, because one of the challenges we have is we have to service, because we service industries is our mission, we have to have a single sign-on solution that can take both certificates.
Sure, it'll work as well from the commercial side as well.
Other question, yes, right there.
So this is a dumb question. How do you pay for AWS? We're all familiar with the credit card model. We don't do that in
Sure.
the Army or DOD.
Well, okay.
That's a very good question. I mean, that's a good question, and I get that. I get asked that quite a bit as a system owner. How did you contract for AWS? First they say there's no contract vehicle. Well, there are contract vehicles. So the contractor vehicles and AWS is on GSA contract schedules. But the easiest way I found as a system owner is to engage my contractor. I know that the Army is pursuing commercial cloud contracts, so they're going to let a vehicle where system owners and others can come in and buy off the contract. However, when I look at that, I say, well, that's okay, but I'm only one guy, and I can't manage multiple contracts if I have to do my Akamai contract, if I have to do my HP contract, if I have to do my AWS contract. I can't do that. So while I do get charged, the government does get charged a little bit more for the service, I turn to my contractor, HPE, and I say, look, you guys manage it for me. I wrote the requirement into the contract for cloud service. The selection was made by HPE that we went with Amazon after a number of reviewing a number of requirements. The same thing is on the Akamai side. I go to HPE to pay my Akamai bill. And then when this contract comes up and recompetes, then whoever inherits the new contract would then also inherit the HPE bill, or the Amazon bill, and the Akamai bill. And if we have to engage another service, if we had to go out and pay for, let's say, C&D services from another agency, and let's say it was a contractor, I would say, HPE, go out there and obtain network defense services.
So the variability part, does that pass back to you, the savings, like they were talking earlier about the fact that it used less than what you really thought you needed?
Oh, absolutely. But we only bill Bob for the service that we actually utilize. So one of the things that I was speaking about and it was consumption of different size servers. And so if we decide that we're going to use 16 cores or more RAM or any of that from a technical perspective, then that's what we utilize and that's what the bill represents because that's what Amazon bills us. We basically take our bill and we have a reseller agreement and with Amazon and so all the different accounts that are on our bill, he has a component of that represents his charges, and whatever he consumes, whether it be storage or computing capacity or whatever else, is what he has to pay for. Now, he does take advantage of reserved instances and things like that, and those obviously have different arrangements and agreements. But in gist, it's about if he's only using 2 servers for his app tier or 10, then he's paying for the 2 or the 10, but he's not always paying for 20.
And I think the other key point here is that we work in partnership. We want to get the most value we can to Bob and as our client. So we're always trying to manage that cost because one of the key reasons he went there was cost savings and agility. And the more we can get, the more
Right.
capability.
Right.
The happier he is.
Right here.
Yeah, you mentioned that it was 6 weeks to get the training instances into the cloud. Can you comment on how large of a application that is, how many servers and stuff, and then what size the team was to be able to do that?
Well, we started, TAMIS had 6 servers. I mean, from an application sizing perspective, I think there's probably a little under 1 million lines of code, maybe 270,000 executables. So it's a typical architecture, with your web server, database servers, and we had an e-signature server, and so we had some different components going on, and so we were using JBoss for application, and so that gives you some sense of the size. Maybe you can add a little bit more.
Once we went to, that's exactly accurate for the initial instance. The second, or the delivered infrastructure as a service that was highly available, represented about 20 or so servers. We had high availability configuration at the database tier, application tier, directory access, and a variety of other components that were there. So we ultimately ended up delivering about 20 servers for any particular instance.
It took about, about two people to go through an assessment and take it through the vulnerability. And again, we looked at it as Bill said, both from a functional technical perspective, but
2 people.
Identifying those vulnerabilities was a critical part.
Yeah,
right?
2 people, about 3 weeks for the assessment of the maybe a little bit longer for the assessment, and then as we mentioned earlier, there's a full development support team that's in place, and we utilized them as we needed them in order to be able to deliver the application because they have the expertise in terms of the code. So
Plugging up the vulnerabilities.
But yes.
And then after this,
refactoring the database, plugging the vulnerabilities, re-architecting the application tier to use DynamoDB and all those
But
things.
one of the most important aspects of this is the training that's available through AWS. So we made it a point to make sure that the technical team that was responsible for this attended the Amazon training. I think that's essential, and it shows up in a number of our after-action reports that we provide and have provided, that the training and the skill of the individuals doing this is important. And where do they get the skill? They go to school on Amazon.
Yeah, go ahead.
I think over here on the right, right there.
Yeah, so I'm curious whether or not you have any sort of general rules of thumb after this experience to say, well, this is a really good app to move to the cloud, but some other general rules of thumb might point to one that would be a lousy choice to move to the cloud. Or is it just that everything should move?
That's interesting because as far as general rules, I hesitate to put them out in this forum, but what I will say is that a part of our offering from an application transformation to cloud is what's called an ASM for C, or application suitability mapping to the cloud. And we have an assessment in which we have a significant number of patterns that we understand and evaluation criteria that we walk through that basically identifies cloud patterns and cloud anti-patterns. And it allows us to quickly assess an application and tell you whether or not it's suitable to stay in a dedicated environment, to move to a private cloud environment, maybe a public cloud or a community cloud like AWS GovCloud, and if you do, where those holes are. And part of what comes out of that is not only the assessment and the recommendation to the target environment, but if you also want it, we can do an evaluation of the gaps and maybe put together a recommendation in terms of a roadmap for the application or a portfolio of applications. Our capability is not just for a single application, but it's about assessing a portfolio of applications and also understanding which ones we want to migrate from a rationalization perspective, and there's a variety of characteristics that we would look at from a rationalization.
I understand you might not want to share your secret sauce. I'm
Yeah.
sure your client would offer anything.
Well, my biggest take, well, you know, the Army has a rationalization process that we go through as well. And it's led by the PEO EIS. We have an organization that's set up that's designed to assist system owners to migrate. Not all system owners have the capability that we have on our team. Some system owners, they don't have the technical experience, and there's a place for them to turn to. My biggest takeaway, and I mentioned it before, is to make sure that the folks that are conducting the move are trained by Amazon or go to the Amazon training. That's the biggest contribution that I can add, because without that, it's you know, you're telling someone, hey, go stand up a VPC in Amazon. You can do it for no cost out of your bedroom and learn how to use it. And so while that's a hobby shop way of doing business, it's really important the government to encourage the contractors to go seek the training before they attempt to go through the migration process.
There were 3 lessons learned that were really important, and that was one. The second one was truly understanding the technical architecture considerations. And that you get that by going through the training and experience and going through those certifications. And once you've got those two, the third thing that we learned is that the financial impact or savings that you get out of some of the architectural considerations and the change in terms of thinking, in terms of the way that you're going to consume the infrastructure, the savings are more significant than you actually imagined them to be when you did your initial pricing. So those are the 3 things that, if I were to roll up the lessons learned, and we had a chart that was around 10 or so different things, those are the 3 things that came out of this. I think we've got some questions from the back that we haven't had a chance to get to.
We got a couple minutes, so maybe a few more questions. Go ahead. So, go ahead.
You describe this as a lift and shift, or lift and shift type of deployment, but it sounded like there was some refactoring that had to be done to get this application to work. So I guess I was just wondering if you could describe, what would qualify this particular implementation as a forklift versus, another type of implementation that would be
Sure. So the definition of forklift in AWS vernacular is to take the application and port the application with minimal change into the AWS environment, regardless of whether that's a binary rehost or a lift and shift or a recompile and lay it in, and even some minor things that might be part of refactoring. Our strict definition of what we did is a rehost. We rehosted the application with a recompile. And we actually did some very minor refactoring in order to get the application running. And you're absolutely correct. There were a blended set of things that we did in order to get the application up and running. But the key was that the definition of that phase was don't do anything that changes the functionality of the application. Don't do anything that changes the configuration or the capabilities in any way that you don't absolutely have to, and do it as fast as possible so that we can realize that we can use the accounts, we can use the services, we can actually shut down the legacy environment if we want to, and we can prove out our testing capability. After that, let's go to optimization. And I want you to drive efficiencies technically and financially for me through those optimizations. And we started at the database tier and we ended at the application tier. And we created high availability, greater resiliency in the environment. We upgraded the architecture to be able to support some of the concerns or bottlenecks that we saw from a reporting perspective, made it more reliable from that perspective. And then at the application tier, we started to scale horizontally. We saved money on the size of servers, the number of servers, and the capacity that we were using. We made it highly available. And then we began to start bootstrapping, which basically allowed us it helped in terms of our deployments, because we can roll out code by simply knocking servers down and bringing them back up. And quite frankly, that's one of the things that helped us in terms of our testing as well. So
I think just to supplement Bill's point, so when we look at this from a cloud perspective, is it three things to consider? Cloud, and it's kind of a continuum: cloud hosted, cloud aware, and cloud native. And you guys probably all know this, but get it into the cloud, get it, not really do too much to it. Then make it aware of the cloud, enable those services that we can start to take advantage of. Sure. Not just the cost savings, but some agility and maybe some additional services. And then eventually get it into a cloud native, where then that's where we're at right now, enabling a lot of functionality and a lot of new capability, like mobility and some other aspects, building the microservices, turning it on. We found that the core services that we needed to make it cloud aware,
sure,
there's a whole slew where what we essentially needed for TAMIS, based on our assessment, was much smaller than the whole
than
suite.
What we truly use, yeah.
And then we eventually factored the others in. I think we're out of time, but I want to, we're downstairs in booth 703. If you guys want to come down and stop by, we'll happy.
Thank you. Thanks, Bob.